Hello. I'd like to say a few words today about my neat new Celestron C90 magnetop Cassegrain telescope. It's defined as a spotting scope, meaning you are supposed to be able to use it to spot things. Comes with a erector 45-degree diagonal and a 32 millimeter wide view eyepiece. It has a 8 by 21 finder scope, 90 millimeter aperture, 1250 millimeter focal length, which gives it a focal ratio of 13.9, almost 14. It's similar in many ways to this little Celestron travel scope, in that they're both small and light, have a little finder scope, have 45-degree vector diagonals, and they both come with a backpack. You can use a camera tripod for both of them. They're both designed to pack up and take out in the middle of nowhere and look at stuff. There's a lot of differences, however. This, as of this morning, this retails for $119 on Amazon, which goes for $269. There's several reasons for that. For one thing, this is all plastic, 100% plastic. This is all metal, 100% metal. Plus, this has a 70 millimeter objective, an achromat, simple achromat. This has a 90 millimeter meniscus lens, plus a 90 millimeter spherical mirror. So since it has two objectives, it's what they call a catadioptric. It's one reason it's heavier. The travel scope weighs a pound, maybe a pound and a half. This 2.5, maybe 3 pounds, in spite of its small size. It does come with a 1 1/4 inch adapter. You can actually take that off and insert some other 1 1/4 inch equipment. Although the folks will get in the way, as they always do with these little telescopes. There we go. As you can see, looking down in there, it doesn't have a very wide tube. Oh, speaking of tubes, it has a tube inside it. Let me show you. Now, this is a Schmidt Cassegrain, which is slightly different. They're both the same in many respects. Light comes in, it goes through a corrector plate or a meniscus plate. The difference there is the meniscus plate is thicker and varies in thickness. This is level. Well, it's curved, but not a lot. Hits the back mirror, goes up here, hits the front mirror, then goes back out the rear. That tube right there is where the light path goes once it's bounced off this thing. This is the secondary mirror. So the secondary mirror fits here. Light comes in, hits the rear mirror, goes up, hits this mirror. By the way, unlike a Newtonian with a magnetop Cassegrain or a Schmidt Cassegrain, the secondary mirror is curved, which adds to the focal length and the magnification. Now, magnetop Cassegrain might seem like a strange name for a telescope. The Newtonian was named after Isaac Newton. The refractor was just named after nobody. The Cassegrain telescope, a fellow named Laurent Cassegrain made up the idea that with his reflector, light would come in, hit the mirror in the back, and instead of being bounced up and then coming out the side, it would go off the secondary mirror and go all the way back down and come out the rear instead of the side. That increased the focal length and magnification. Then a fellow named Dmitry Maksutov, a Russian guy, came up with the idea of, instead of using the Schmidt corrector plate, he made up his own corrector plate, which corrected for more things. And therefore, the Maksutov Cassegrains cost more than the Schmidt Cassegrains. I took this out a couple times in the daytime. I found that this little 9x21 finder scope worked marvelously, because the field of view on this thing is so small. If you want to see a sign like 4 blocks away, I did, you really can't aim it and find it in the eyepiece. What you have to do is align the finder scope with the optical tube and find it in the finder scope first, which has a much larger field of view. I like the finder scope a lot for terrestrial use. When I took it out at night and used it, I found that I couldn't bend down far enough to see through it. I have to like lay on the ground to look up through that thing. So I went ahead and used this one, another $89. It's what I always use when I'm looking for the moon, and that's what I was doing. I can turn that 360, so I can sit in my chair. This has a much broader field of view than that little one. This is 50x9, and find it, and then I zeroed this in, aligned it with the optical tube a couple days before I went out at night, figuring I might need it, and I did. So if you're going to try to find something using a finder scope, you're going to need to spend an extra $90 or so and get one of these. What else? Oh, the 45-degree erecting diagonal is fine and dandy for terrestrial use. I liked it. It was neat. But if you're going to try to use it for astronomical purposes, you're going to need to get one of these. They're about 25 bucks. That's a 90-degree diagonal. That way you can look down into that when it's pointing real high and not have to lay on the ground. Other than a 90-degree finder scope and a 90-degree diagonal, that's really all you have to add to this to make it a astronomical instrument. It has a smooth focusing knob right here, and I found that just like my Schmidt Cassegrains, if I have this set for point blank, it takes about 52 turns to get it to focus across the street. And once I got it focusing across the street, it only takes 12 or 15 turns to get it to focus into space. However, that little silver-looking thing, Maksutov Cassegrain doesn't actually have a return mirror like the Schmidt Cassegrains. They just painted a return mirror onto the glass. So inside here, in the meniscus lens, there's a aluminized paint thing that reflects the light back. And since the meniscus lens is curved, the painted area is curved as well, so it helps with magnification. That makes this, it takes up 23 millimeters of room, diameter, and a 23 millimeter diameter return mirror and 90 millimeter scope. If you take pi r squared minus pi r squared divided by pi, what you end up with is this 90 millimeter telescope only collects the same light as an 80 millimeter refractor. You lose some of the you lose surface area. In addition to that, since you got light bouncing all around inside here, every time you bounce light, you lose a little bit of the light. So this doesn't even pick up as much. Well, when you look through this, it's not as bright as an 80 millimeter refractor. I did a comparison between this and the 90 millimeter refractor I have, the Sky Optics thing there. I'll make a video of that and post it. I can actually see things with this I can't see with this. And this is just a little plastic 70 millimeter job. It's a wide field refractor, so it has a larger area. In fact, the field of view of this optical tubes actually about as big as the field of view of the finder scope. That's why I never used the finder scope in this. When I had to review this, I put it on backwards since I had never used it. But I fixed that since then. This, however, doesn't have chromatic aberration. Doesn't have spherical aberration. Doesn't have coma. Gives you pretty good shaped stars. That's the advantage of the meniscus lens and the catadioptric design. I did take some photographs with this the other night. I took a photograph of IC 4756, grass cluster, an open cluster. Came out fairly nice. I then took a picture of M11, wild duck cluster. It's got a lot of stars. And that came out okay. I took a picture of M16, Eagle Nebula. I was kind of surprised. That came out pretty nice for a little $269 telescope. And I took a picture of M17 Omega Nebula. That came out pretty good too. I also tried to get a picture of Trifid Nebula, but I wasn't using a filter with this thing when I was taking these pictures. And I live in a real light polluted area, and Trifid Nebula was right there. I'm 12 blocks from a big oil refinery, but I'm 3 blocks from a college, which has a lot of light. So if you get too low on the horizon, pointing south, you can't take pictures of nothing. And this thing, they were too low on the south. I had a couple of them there. Yeah. What do I think of it? I think it's a great terrestrial scope. If you're into shooting and you have a Shiloh Sharps 4570, you want to shoot at 2-foot metal plates at 2,000 yards, you'll need to get one of these and a tripod and have your spotter tell you how much you missed by, because there ain't no way at 2,000 yards to tell where the bullet hit. But they can see where the puff of dust hits, or they can see the metal thing move. They hit the metal and tell you, up 3 over 4. And that's the primary use for these things, is spotting, either for gunfire or. Well, the other day, I was saying, I wonder if I can see that little sign. There's a little sign about 4 blocks from here. Can't see it with my naked eye. So I rotated this thing over, and found it in my small finder scope. But in the finder scope, I could see a robin sitting on a tree branch. I looked in the eyepiece, and sure enough, there's a robin, a female robin, sitting on a tree branch. I couldn't even see the sign that the tree was next to. Certainly couldn't see the robin. So if you have a good idea where you're looking, this gives great terrestrial views. Better than this. Better than my refractor, but narrower field of view. $269. I wouldn't recommend this as your first scope. I might recommend this as your first scope. Quick, easy to use, foolproof. You'll outgrow it pretty quickly, but if you're only spending $120 on it, it's very easy to use. I might even recommend one of those, Sky Optics 90mm, but only if you already have a stable tripod of some kind and mount, because it doesn't come with a mount. This at least comes with a camera, which is all you need. Would I recommend it as a second optical tube? No, because when you outgrow something like this, or like my LT 70mm Celestron refractor with the handlebar mount, when you outgrow your first telescope, you're not going to want something this specialized. You're going to want a bigger telescope. And by the time you've played with your first telescope a while, you ought to be ready for your second as a Newtonian reflector on a equatorial mount. And this costs $119, but for $779, you can get a nice 150mm reflector, Newtonian, on this mount. And that will last you, well, theoretically, the rest of your life, because it gives great views, takes great pictures. It's a great medium-sized everything, and that might be all you ever need. But if you decide to start taking pictures of the moon and Jupiter and other planets and stuff, these things are really, really good at lunar and planetary work. I'm going to show you one of the pictures I took. Oh, I didn't tell you about it. I left it off the list. Here's a picture I took of the moon. I took just a couple of nights ago. I don't have a Barlow lens or anything in it, and I didn't take video and then run it through PIP and auto stacker. I just took a 1 second 1 second zero gain snapshot. No, it wasn't 1 second, it was 1/30th of a second zero gain. I just took a quick picture of it. Came out pretty good. Now, if I wanted to do serious work, I would put a Barlow lens on it and zoom in closer. Then you'd have just got to see a crater instead of a crescent. Yeah, that's all I had to say. So until I see you again, happy trail.